show you tonight is a .NET project I just got set up with that I had a lot of fun doing. So if you go down here, as for the Flare VM, I've added this .NET. We reverse a couple of .NET executables. And I was glad to do it. So you get some samples here. And we're just going to see several tools that we haven't used in this course yet that are included in the Flare VM. And you can put them in other machines if you want to, but if you use the Flare VM, they're already pre-installed and ready to go. So the first thing is I've got samples, and let me, maybe I'll just download that file again. That's probably the thing to do. Copy link address. Let's see if I can fit this junk on my screen. It looks pretty good. Okay, let's open Firefox. All right, it's going to ask me a stupid question. All right. Paste and go. All right, so there's my file. I save it. And good, there it is. Let's extract it. Okay. And now I've got a folder, good, with that folder, and in there's two files, challenge1 and PMA. And you can't, if you double click these, you can't just run them. For some reason, 32-bit.NET won't run here. Now that's some garbage about it being unrecognized, but even if I fixed that, I think it still won't run. Let's unblock it. Oh, there it goes, neat, okay, that's all it was before. So it runs. It shows you a picture of Bob Ross. I got this from the FireEye Flare VM, Flare contest. And when you decode, it turns this into drivel and changes the picture. So the point is this decoding process creates junk, but in fact, it first decoded to something readable and then changed it again to something unreadable. So like we've done with a lot of malware, the point is you want to catch this when it's decoded far enough to be readable, but not when it proceeds further to scramble it. But if you were to open this in a debugger and mess with it, you can't get a lot of good out of it. Now here, I ran it in x64 debug just so you can see it, but we can't really debug it effectively in x64 debug. And the reason we can't is because it's not an ordinary executable of the kind we've been using. If you right-click this and open with CFF Explorer, it will show you right here, this is a portable executable 32.NET assembly. And .NET assembly is a lot different than raw executable assembly code, raw executable machine code, which is what we've been using, which we can disassemble to assembly code and then run through things like debuggers. .NET is partially compiled code. So to explore .NET files, you have to use a different tool. The point of .NET is it's instead of being compiled down to machine code for your hardware, it's partially compiled down to bytecode, which is also how Java works. And then the bytecode runs in some kind of local virtual machine. And so this is called Microsoft Intermediate Language, which is some kind of platform-independent binary language. And then you need, this abbreviation IL is used for that language, and there are various tools that use it, that help you see it, and the one we're going to use is ilSpy. So let's get rid of that and run ilSpy. And of course, that's already included here, which is why I'm using it. All right, and so one thing that really baffled me about ilSpy is that it keeps old things around that you're done with. You have to manually remove them. All right, so now this is the way ilSpy will look at first. It opens a bunch of stuff which is used to run the assembly code, to run the .NET code, and then you have to load the program you want to analyze. So that is going to be downloads. And, well, all right, it's PMA 132. There it is, challenge 1. Okay, now I've loaded this challenge 1 thing. And I don't think I can change the font. Let me see. View options. I think I can change the font. Let's make it bigger because I think it will improve the streaming. All right, doesn't make it all bigger. But anyway, it makes this part bigger, which is good. So over here is challenge 1. It's a .NET framework, and so it is just a tree-structured object here. All the parts you can see are just here. And as we're going to see, the important thing for us is that the assembly code is the source code is included. .NET is a language-independent bytecode. So you can write Visual Basic or you can write C++, compile it to .NET and get the same results. And you have the full source code. So this is kind of mind-bending if what you're used to is compiled C++, compiled C. So there's a thing in here called a form. And if I go into the things inside the form, there is a button to decode. And remember when I ran it, there was an object and there was a button to decode it. That's what this button is. And that button will have this effect. This is the actual code. And when you look at .NET code, it is reconstructed from the bytecode. What's actually stored inside a .NET file, you can go up here and choose what language you want to view it in. And if you go to IL, this is the actual language that was stored. These funny commands that look sort of like assembly language. That is .NET binary. But this is not x86 assembly language or x64 assembly language. It is a higher level .NET bytecode. And you can convert it back into other languages. This one only supports C#, but you can also reverse it back to Visual Basic with other tools. And when you do, you've got everything. You've got the names of the variables. You've got readable code. This is not like other decompilers. The entire source code is included in the program you hand out. So it's very handy. We can do basically source code analysis here. So we can just read this. And so you can see how what that button does. It reads something called dat secret, and then it just interprets it this way. This just takes each byte and it shifts it to the right by 4 bits, which takes the left 4 bits and puts it on the right. This takes it and shifts it to the left 4 bits and ANDs it with F0, which keeps the left 4 bits. So it takes the two nibbles, the two 4-bit parts of a byte, and flips them. And then it just XORs it with a fixed value 29 in hexadecimal. So this is a very simple scrambling routine. So if you want to do it yourself, you could easily implement this in Python or any other language. This is a very simple operation. And then you have to find out where's this dat secret. And that is also just available. So if you go down here and mess around in this thing, you can find it. It says resources dat secret. So down here we got resources, and in there we got dat secret. And I might have to hunt around a little more to find it. Here's resources. All right, I saved a picture of it. To find that, it is up here in metadata resources. Okay, what I'm finding there is something like the information about it. It was up here, metadata resources. There. Here it is, dat secret and code. So there it is, and you can just save that file from here. So I save that file, and I'm going to put it in the same folder, and I'm going to call it dat secret, getting rid of all this extra text that I don't care about. So it has the expected name. So there is the dat secret. So now all I have to do is I have to perform this mathematical operation. Oh, by the way, what's going on? This is the first decoding step, which makes it readable, and then it goes through another scrambling step which makes it unreadable. So all I really have to do is implement that in another language. And that turns out to be pretty easy to do in Python. I don't think I'll keep doing it because that part is not that interesting, but it's here. So here's the Python code that does it. You read the dat secret. You can just do it in Python. It's very much the same. You move it, shift it to the right 4 bits, and OR it with this one shifted left 4 bits, and it's very much like the C++ code, the Python code. So then you can find the flag that way. So this is one using the original one from the Flare-On challenges, and I modified it. So you have another file which is a little bit different, and you'll have to analyze it and modify the code to find the hidden file inside there. And then just before class, I found another one. I went through the Flare-On challenges to see if there was another easy .NET one, and there is, and it's Memecat. So let me get my I think I'll just download it again. Copy link address. So if you go here, get rid of that, go back to Firefox. It's the Memecat battle station. Wait for it to ask a stupid question. Oh, well, just a moment while I fix that. Memecat battle station is not up on my server, then you're not going to have any fun. It is, all right. Well, let me find it. It's in here. And I think I put it in the documents folder. Yeah, there it is. All right, let me copy it. Paste it onto my desktop out here and put it on my server where it belongs. That's rude. You aren't going to be able to do this project without that file. Wait, it's already in there. All right. Oh, I know what happened. I did it by sorting by date, and this Memecat battle station is, of course, a couple of years old. So I need to find it by name. Okay, and then I need to put it up on my server. 3 seconds remaining. Okay, now we should be able to download it. There we go. Okay, good. See how that looks? Look like it's just finished. Good. All right, so there's Memecat battle station. So when you run this, it complains that it's unknown, so you have to go to properties and unblock it, and then you can run it. Now it's going to threat. I don't know what this threat garbage is. Okay, good. Anyway, so here it's a game, and there's the game. This thing is coming, and you have to shoot it, but you have to get the arming code. So if I put in password, if I don't have the right arming code, then the fire button does not work. Invalid weapon code. So I have to figure out the weapon code, and then after I get the first one, there's a second stage where I have to find another weapon code. So you're going to need to figure out what the basically passwords that are missing here are. So as you can imagine, this is pretty easy. You use ilSpy, and since you have the source code of the game, it's not too hard at all. The one thing that irritated me to prepare these is that this old one just stays in here, so you got to get rid of the old one you're done with, and then add the new one. And that is downloads, Memecat. There it is. All right. And so here's Memecat battle station, so you have to expand it. And that's metadata. That's not very interesting. Here's the battle station. And see, here's stage 1 and stage 2 forms. So it's pretty obvious what you have to do. Use stage 1, and down here is a fire button. And this fire button only works when you have the right thing. So you hit the fire button, and right here you can see if code box text is rainbow, right there, then it's able to fire. So here it looks like the first problem is rainbow. So let's take a look. Now, I don't know if this program freezes it. Let's see. If I run this, it looks like it runs. Okay, so let's see if rainbow works. Make it up bigger so I can see it there. Rainbow. Okay, fire. Okay, rainbow works. And now I have another one that I have to solve. So the second one, I go back to my ilSpy, and I go to stage 2. And in here, there's a fire button. And the fire button here calls a function called isValidWeaponCode. So I have to find that, but it's just right down here. And then you can see there's some kind of encoded data, and there's a decoding process, which is very simple. So again, you can pretty easily do this in Python or other ways. You won't have too much difficulty turning these binary values back into the readable code. So anyway, that's .NET. People use this thing, and it is much simpler than other executables. So anyway, I was glad to have a couple demonstrations, and I should also mention, if you go to the end here, you can see where I got these. Irvin pointed this thing out to me, the Blue Team CTF challenges. This is an amazing place where they gathered a whole bunch of open source challenges, including all of the flare-ons. There's been 7 of these. Every year they have another one and a bunch of others, packet analysis ones and all sorts of things, MAC analysis, reversing, so many good things here. So I went through and found a few, but you can find a lot of good things to do here. And of course, a lot of them there's write-ups. If you get stuck, you can Google for it. These are old challenges from old CTFs, and people have typically written blogs about them and stuff to guide you through it. So anyway, tons and tons of good challenges. I'll probably be adding some more. So anyway, that's what I wanted to show you.